Hello everyone, this is Dr. Shrikant Arle, and in this video we will be solving a problem related to the rigid base circular water tank. We will first of all write down a problem. So a problem is a circular tank has an internal diameter of 10 meter and has maximum height of water as 4 meters. The walls of the tank are restrained at the base. Design the tank. Assume thickness of wall as 160 mm. Assume thickness of wall as 160 mm. So this is a problem where a circular tank is to be designed. Now it has internal diameter of 10 meter and maximum height is given as 4 meter. Walls of the tank are restrained at the base, so this means it is a rigid base water tank. So now you need to design the tank and you need to assume the thickness of wall as 160 mm. So we'll solve the problem, and this problem consists of the different steps. Step number 1 is the calculation of hook tension and its position. Then calculation of moment at the base. Then we will calculate the shear at the base. And then we will design the section for cantilever action. We will also calculate development length. And then we will design the section for hook action as well. Then we will go for the distribution reinforcement, and then we will provide the haunches, and lastly we will provide the design of base slab, and based on this design we will draw the reinforcement details. So we'll go step by step. So first of all, step number 1, that is calculation of hook tension and its position. So we can write down here step number 1. Calculation of hook tension and its position. So now here thickness is already given to us, that is thickness which is denoted by T, that is equals to 160 mm, and if we just convert in terms of meter, so that is 0.16 meter. Now we have to go through the table number 9. So I'll write down from table number 9 of page 35 of IS 3370 part 4 of 1967. So if you just go through this page number 35, table number 9, so you will get something coefficient, and that is based on h square by dt ratio. So we need to first of all calculate h square by dt. So h square is already given, that is 0.1, h square is already given, height is already given, that is height is given as height of water tank as 4 meter. So we can write down here 4 meter, it is the height, and diameter is given, that is internal diameter, and this is 10 meter, this is the internal diameter which is already given in the problem. So we can write down 10 and this multiplied by 0.16, it is the thickness. And now you need to calculate this ratio, h square by dt ratio you need to calculate, and depend upon that we will just take the coefficient from table number 9. So this is coming out to be 10, and from the table we got the coefficient, and that is equals to 0.608. So 0.608, it is the coefficient what we got. Now if we just look at that at the same page, the formula is given for the maximum tension, and that maximum tension is equals to coefficient multiplied by WH into D by 2. And from here you will get the maximum tension, right? And this maximum tension is going to be occur at 0.6 H. This is at the 0.6 H. So if you just calculate from the 0.6 H, so the 0.6 H will be coming out to be, so at the distance of 0.6 into H, and this is 0.6 multiplied by 4 meter, and that is coming out to be 2.4 meter, and this is from the top position. So this is what we got as the maximum coefficient depend upon the h square by dt ratio.